Hey guys, my name is Kevin Wang, and today we're going to talk a little bit about chain rule. Now, chain rule is a rule that states that when you have a function, let's say capital F of x, that is composite of two functions, it can be written like this or like this, then the derivative of capital F of x is equal to the derivative of the outside function of the inside function multiplied by the derivative of the inside function. Now, the chain rule is a really ubiquitous, really important rule that you're going to see come up a lot in ways that you don't really expect when you're doing a lot of calculus involving derivatives. Now, let's take a look at some examples of the chain rule in action. So let's take a look at an example problem. Let's say we have h of x is a composite of f of x and g of x. We're given that f of x is equal to 2x plus 3 and that g of x is equal to 4x squared plus 1. And so the chain rule states that the derivative of h of x would be equal to the derivative of the outside function with the original contents, so that would be g of x, times the derivative of the inside function. And so when we substitute in the values that we are given, say, let's start one at a time, f prime of 4x squared plus 1 times, now we use the power rule to find the derivative of g of x, which we find is 8x. And so the derivative of f of x is going to be 2. And so there's no x in that, so it just becomes 2 times 8x equals an end result of 16x. Take a look at what happens when you have exponents in chain rule. This is where you're going to see a lot of examples of having to use chain rules when taking derivatives. So let's say we're given f of x equals 2x plus 3 to the fifth. Now we're asked to find f prime of x. Now you could actually take 2x plus 3 to the fifth, multiply it 5 times, do a lot of algebra, or you can use the chain rule. It may not immediately jump out to you, but this function is in fact a composite of two functions. They just haven't been given names yet. So 2x plus 3, this expression, it can be a function by itself, so we'll call that g of x. And this expression being taken to the fifth, x to the fifth, that is its own function. So when you write it out like this, it's a little bit more clear that f of x is a composite of h and g of x. And so we know, using the chain rule, that the derivative of f of x will be h prime g of x times the derivative of g of x. Then we substitute in values. H prime of 2x plus 3 times derivative of 2x plus 3 is going to be 2 equals 5 times 2x plus 3 to the fourth with the power rule times 2, and gives us an answer of 10 times 2x plus 3 to the fourth. So let's take a look at chain rule with nested functions, or basically functionception. So like a function of a function in a function in a function, like functions within functions. It gets kind of crazy, it gets kind of hectic, but chain rule still applies. So let's say still got f of x, and f of x equals sine of cosine of tangent of 5x cubed minus 7x to the fifth, because why not? Alright, and we're asked to find the derivative of this crazy thing. Still the same procedure, derivative of the inside derivative of the inside times derivative of the outside of the inside. Except you just have to do it multiple times. So let's start from the innermost function right here, 5x cubed. Derivative of that is 15x cubed. Oops, excuse me. Derivative 15x squared minus 7 times derivative of this whole thing with the fifth power. So you use power rule, bring down to 5. 5x cubed minus 7x to the fourth times, now for those that don't know, the derivative of tangent is secant squared. Secant squared of the original function inside times, again, cosine, derivative of cosine is sine, sine of tangent of this whole thing times, finally, sine, it turns into cosine of tangent of 5x cubed minus 7x. What a beast. The rabbit hole just keeps on going down, down, down. But you just have to make sure that every function gets its derivative. Now, for my last example today, we're going to take a look at how the chain rule interacts with implicit differentiation when you're trying to find y primes. So let's say we're given y equals x plus y squared, and we're trying to find y prime, which equals dy over dx, which we're just going to keep as y prime to save some time and space. So, to do this, we take this whole equation, take its derivative with respect to x, then we get y prime is equal to, using the power rule, we find 2x plus y times, and then the chain rule, find the derivative of inside 1 plus y prime. Then we do a little bit of foiling, and we get 2 times x plus xy prime plus y prime. And that's the end of the chain rule, but we've still got to find the y prime. So distribute into 2, x plus 2xy prime plus 2y plus 2y prime. Then move all the terms with y prime over to one side. Minus 2xy prime minus 2y prime. 2x plus 2y. Y. Take out the y prime from each term. 1 minus 2x minus 2y. 2x plus 2y. And then y prime is equal to 2x plus 2y over 1 minus 2x minus 2y. So chain rule has quite a few places where it's pretty easy to go wrong. So going back to the example that we used in the exponent, f of x equals 2x plus 3 to the fifth. Most common two mistakes that are made when applying the chain rule are forgetting to multiply by the derivative of the outside. So this would give us f prime of x is equal to 5 times 2x plus 3 to the fourth without the extra 2 over here that should be over here. And of course that's a completely different answer. And the other common mistake that's made is putting the derivative of the inside function inside, which would give us 5 times 2 to the fourth, which is also a completely different answer. And so the only ways to really not make these mistakes is to stay vigilant, and if the problem allows for it, you can try to check your work by using the definition of a limit. And you just gotta stay vigilant, and you just gotta remember the chain rule really clearly. Practice really helps out with this a lot. So this has been my video on the chain rule. I hope that you enjoyed it and that you learned a bit about the chain rule.